Hello everyone, welcome to the second project of Ionots IoT goals. In the previous project, we have already seen that how to control a LED light using a web page. In this project, we will build a smart light system to minimize the electricity usage. There will be two LED lights that can be controlled by different inputs provided. One of the LED light will be controlled based on the output of LDR sensor and the other LED light will be controlled using the blink application. Now, moving on to our project, this is the list of components that you require. And the hardware part, I hope you all have all the components mentioned here. And in the software part, you guys already have the knowledge of Arduino IDE and blink application from the theory part. Now, moving on to the procedure. As mentioned in the step 1, open Arduino IDE, copy and paste the source code in it. As you already know, the source code is mentioned at the end of the procedure. So here is the source code. I'll just copy this source code, go to my Arduino IDE and paste it there. This is the source code for this project. Now I'll quickly save it on my desktop. Now coming to the step 2 of the project, open Blink application in your mobile, set up your Blink account. We have switched to a mobile phone so we can configure our Blink application that will act as one of the input for our project. To do that, first of all download Blink application in your mobile device. You can download it from Play Store. Search Blink and here you can see this is the application that you need to install. I've already installed this application, so I'm gonna open it. When you open it for the first time, it will ask you to log in. You can simply log in using your Gmail ID. Now, after logging in, it will take you to this screen where you can create new projects. To create a project, tap on New Project and here you can see a project name. Give it a name. Now, after giving it a name, select a device. We are using Node MCU, so we're gonna go with that and select a connection type. We don't need to change our connection type because we are using Wi-Fi itself. Now tap on Create. As you can see, it is showing an authorization token was sent to respective email ID. Now click OK. Here you can see a graphical user interface where you can add controls and output screens to your project. We will need to add a button to switch on and off the LED light, and to do that, click on the plus arrow on the top right of the screen. And here you can see all the functions that you can add to it. We will add a style button to our project. As you can see, a style button is here. Now to configure this style button to match with our LED, tap on this style button and here you can see all the settings that you can do. Give it a name, LED2. You can give any name you want. I'm just putting LED2 for our ease. Now select the pin that you're gonna connect your LED. Do not select D0 because Another LED is using D0 already. Select D1 or D2 or D3. You can select any pin till D10 from D1. I'll go with D1. Now change to switch. So you don't need to tap again and again to turn on the LED. Now choose a background and off background. And here you are. As you can see, a button has been created that will control the second LED for our project. Now we are done with the configuration of Blink platform. We will move forward with the next steps in the lab manual. As you can see in the lab manual, step number 2, 3 and 4 are regarding the configuration of Blink platform. We are already done with that, so we'll jump to step number 5. Here, step number 5 says, place your Blink authentication token, your Wi-Fi and password at the required place in the code. We'll move back to Arduino IDE. In the Arduino IDE, here you can see three characters. First one is auth, that represents authentication platform, Blink platform. Second one is SSID, that represents Wi-Fi name. And third one is pass, that represents your Wi-Fi password. We'll remove this hash symbol and place our Wi-Fi name. Now we're gonna do the same with the password. Now for the authentication token, you can check your registered email ID with the Blink and open the mail. As you can see, it says authentication token for project 2 and device project 2. As you remember, our project name was project 2 and this is the auth token that we need to place in the Arduino IDE. Copy this and place it in front of hash. Now our authentication token is here. We will move forward to the step number 6. Step number 6 says, check once whether you have selected the right board and the COM port before uploading the code. Compile and upload the code. We'll move to the Arduino IDE. Here, go to Tools and check Board. Check if your board is right, that is Node MCU 1.0, and check your port. It could differ in different laptops. Mine is COM4, but make sure this port is selected. Now we'll upload the code in the board by clicking this upload arrow. As you can see, it's compiling. That means our selected port is correct. After we are done uploading our code in the Node MCU, we will move on to the hardware assembly of the project. First and foremost step would be removing the USB cable from the Node MCU. This will ensure the safety of your hardware components. Now, we will take a jumper wire and connect the ground of the Node MCU to the breadboard to make a ground plane. Now, we will take one LED. In the LED, it has two terminals. As I explained in the previous project, longer one is anode, shorter one is cathode. We will connect anode to the D0, that is the LED which will act on the sensor output, and the other terminal, that is cathode, to the ground plane that we created. Now we will take another LED with us. This LED will act on the blink input. We will connect, if you remember, we'll connect this to the D1 as we defined in the blink application. So we'll take anode to D1 and cathode to ground plane. We're done connecting our LEDs. Now coming to the LDR sensor. This here is the LDR sensor that you might receive with the kit. We'll connect this LDR sensor. It has two terminals, both are equal terminals. We'll connect them on the breadboard at different locations. Now, one of them has to be ground, so we'll take a jumper wire and connect it to the ground plane that we created. Now, we will take our 10K resistor that is here and connect it to the other terminal of the LDR sensor. And other terminal to the breadboard. Now we'll take a jumper wire. We'll connect one terminal of the resistor to the A0, that is analog 0 of the node MCU. And the other terminal that is across the resistor to the 3.3 volt for the power supply. And that completes our circuit. Now we'll plug in our node MCU to the laptop. And that's all. We are done with the hardware assembly of the project. We have finished our circuit and we have finished our project too, as we have already uploaded the code in the node MCU, so we can move forward with the results. Our project has two parts. One is LDR sensor, other is blink application. Let's go with the LDR sensor part first. Here, the LDR sensor is being used to control the state of LED. If LDR sensor is in light, it will turn off the LED, and if LDR sensor is in the dark, it will turn on the LED. We cannot turn off the lights as of now, but to test the project, what we can do is we can cover the LDR sensor with our hand and observe the state of LED. Let's move forward with that. As you can see, when I covered the LDR sensor, it turned on the LED automatically. When I removed my hand from the LDR sensor, it turned off the LED. When I placed my hand again on the LDR sensor, it turned on the LED. And thus, we can say that this part is working fine. Now we're ready to move to the blink application part. For that, go to your mobile device where you connected the blink application. Now open the blink application. You will land on the GUI of the blink application that we created before. On the top right of the GUI, you will see a play button. Tap on it. This will connect the GUI to the node MCU. Now you will see a button. Its status is off now, and the LED status in the circuit is also off. Now when you tap on the button, its status changed to on and the LED in the circuit is also turned on. When you turn off the LED in the GUI, it will turn off the LED in the circuit also. Thus, we can say that a blink application part is also working. And thus, we conclude our project here. Coming to the application of this project, you can deploy this project in your home or workspace, so you can save a lot of electricity when you're out of the home or when you forgot to turn off the lights. This project can be deployed in many ways. You can customize it according to your need. For example, you can connect the blink LED near the LDR sensor. Thus, it will enable you to control the LED as per your desire. Now, if you have any doubts, you can always ask them in the Google Forms.